All right, we're on. Our objective 5 will be the first distributive practice. It's just refreshing our memory on the patterns of chemical change. We said there are 5 questions. There will be one of each of the patterns that kind of help you if you eliminate choices along the way. In our first one, copper solution with barium nitrate, I needed to, but I don't see it there. Put a Roman numeral into the copper 2 sulfate. Without that information, we wouldn't know what the charge is, so that's an error on my part. It says solutions of copper 2 sulfate and barium nitrate are mixed. Copper 2 sulfate is a compound, barium nitrate is a compound. When 2 ionic compounds react, we have a double replacement category. When CuSO4 is a +2 -2, reacts with barium nitrate, +2 -1. So our 2 reactants, CuSO4 and BaNO3, taken twice. Copper will go to the nitrate, barium goes to the sulfate. Copper, who's still a +2, nitrate is still a -1, so we get CuNO3 taken twice, and BaSO4 with its +2 -2 charge. This equation worked out balanced. We've just found our double replacement. Our second example, mercury 2 oxide is heated. Mercury 2 oxide is one reactant. As soon as I notice I have a single reactant, we can label that as our decomposition pattern. Mercury with its +2, oxide is a -2, so we get HgO, +2 -2. That's now a scribble. Is heated, you may choose, if you'd like to, put a little triangle over the arrow to show that's being heated. Helpful hint number 5 on our decomposition page would say, if a binary compound, which HgO is, it's just a compound made of 2 elements. When binary compounds break down, they release their elements. We get mercury and oxygen. Oxygen, of course, belongs to the lucky 7 club, so it's Hg plus O2, and we'll just go back to balance with a 2-2-1. In our third example, silver oxide is formed. If I'm pointing at silver oxide, silver with its +1, oxide with its -2, we get Ag2O. Again, here's a pattern of change that has a single product. That's called a combination. When silver and oxygen combine, we get Ag plus O2 going to Ag2O. And when we balance, we end up with a 4 silver, 1 oxygen, 2 silver oxide. It's 4 to 1 to 2. Potassium metal dropped into nitric acid. Here we have an element placed into a compound. This would be called a single replacement. Potassium dropped into nitric acid. Hydrogen with its +1, nitrate with its -1. Knowing the acid name ic, we looked up nitrate to find that acid. Pattern would show hydrogen getting kicked out and potassium hooking to nitrate. Balancing will double the acid, we'll have to double the K. 2-2-1-2 balances for that. In the last one, propanol is burned. Probably should have been a little bit more clear in what pattern of change. Do I want complete or incomplete? So I'll have to be careful there. I'll just say, let's make it a complete combustion. In another strategy, we said, instead of writing out all of the C's and H's and O's separately, I like to just combine them. It makes counting easier. So I have 1, 2, 3 carbons, 3, 4, 5, 6, 7, 8 hydrogens, and we have an oxygen. So I'm going to choose to write propanol. Instead of its structural form, we'll write it in a molecular form, C3H8O. Pattern of change says when we combust it, which a hydrocarbon combusts, we'll label that as a combustion. Out comes carbon dioxide and water. When we begin to balance, the strategy says C's, then H's, then O's. That's just the most helpful way to go about balancing these. So I start by counting my C's. I'm counting 3 on the left, so I'll put a 3 on the right in front of carbon dioxide. I have 8 hydrogens, so I'll put a 4 in front of the water. That gives me 8 hydrogens. And now I'll count the oxygens. 3 times 2 is 6, 4 more on the water. We've got a total of 10 on the right. What I'm noticing then is the one oxygen in that first reactant means I need 9 more, and there's no way I can get 9 more oxygens from an O2. Oh well, good try. Back to the drawing board. It says now, since that didn't work, we're going to take that and double everything we just figured out. So instead of a 1 in front of propanol, I now have to double it. Instead of a 3 in front of carbon dioxide, I've got to double it. And now I know to put an 8 in front of the water. That's going to help repair my oxygens. 6 times 2 is 12, 8 more on the water. Now I've got 20 oxygens. If I need a total of 20 on the left, I can now subtract 2 from that reactant, propanol, and now I need 18 more to get it to balance, so I can place a 9 in front of the oxygen. A 2 to 9 to 6 to 8 balances that. If that matches your paper, you can give yourself an A+. I'll turn the video off and we'll take a little moment. Alrighty. When you're ready with this, we'll flip back to number 4, the fourth objective.